All right, so we left off talking about starting with the ventricular filling. Of course, it is a cycle, but that's a good place to start since you got to have blood to move it. And got on the last video into the idea of ventricular systole or contraction that would push blood into each ventricle, topping it off, right? Well, after the atrial systole, after they've done their push, they get to relax, so they'll go into atrial diastole, right? And this, of course, happens somewhere in the QRS complex, so you really can't see it happening. But we know it will. So pressure will begin to decrease in the atria. Well, at the time that it's beginning to decrease here, well, the nodal system has passed on the action potentials through the AV node and AV bundle and to the bundle, the right and left bundle branches and down through the Purkinje fibers. So now the ventricles are beginning to depolarize as witnessed by the QRS complex. And this depolarization would then lead to the ventricles starting to contract somewhere about here. Okay? So here they show you, and we're going to call this contraction again systole, ventricular systole, and they're showing you, at this, that the atria spend a long time in diastole. So now the atria are relaxing and the ventricles are beginning contraction. Now they refer to this as isovolumic or isovolumetric contraction because at this point, when the ventricles begin to contract, what they'll do is the first thing is they'll close these AV valves, the tricuspid and bicuspid. So as they begin to contract, the pressure will go up here compared to the atria. And so if we don't close these AV valves, well, blood just goes spurting back into the atria and possibly back out to the body, which would be a big problem. So at this point, the AV valves close, and they are closed as are the semilunars. So there's no change in the volume in the ventricles, all right? This contraction continues to build because we're going to go for quite a while here before we repolarize, all right? And I also mentioned here that with this closing of the AV valves and the semilunar valves still closed, this would be, right, end diastolic volume. So we're at the end of ventricular diastole, starting right here into systole. And we have now filled the ventricles to the greatest volume we can, which at rest is usually somewhere around 160 milliliters in each ventricle. All right? So contraction keeps on going, and we're going to get to a point where the pressure is so high in the ventricles because of this contraction. See, the walls are closing in, they're shortening, that they will open the semilunar valves, right, in both the pulmonary and the aortic, because now, at this point of the contraction, systole, the pressure in the ventricles will be greater than that in the two arteries, the aorta and the pulmonary. And when that happens, of course, we're going to open, right, pressure higher here than here, we will open these valves, but we'll see this in the next slide. All right, so here I say is getting the semilunar valves open, which is from this transition to this transition, so that we can actually get ventricular ejection, right? So as soon as pressure is greater in the ventricles, then the vessels, the pulmonary or artery or the aorta, we open these and blood will begin leaving. Again, pushed by this contracting, all these contracting myocytes in the ventricle and the force that they are generating, okay? So as long as pressure stays higher in the ventricles than these two arteries, blood will leave. And so we actually measure the amount leaving because that's really a good indicator of your health, right? How much is going out into circulation. And we refer to that metric as stroke volume, all right? So some percentage of the end diastolic volume, right, the fullest the heart can get, will leave. And so it's called ventricular ejection, and we sometimes actually refer to it as the ejection fraction. All right, so after this, of course, after we've depolarized all these the ventricular myocytes and let contraction occur, we are going to repolarize them. as we repolarize, as shown down here with the T wave, going from here to here, we're going to basically reset. So all these ventricular myocytes are now going to start to relax. So we're going to be in ventricular diastole from here right to here. And meanwhile, we are still in atrial diastole, so blood has been returning, but it hasn't entered into the ventricles again because these AV valves are closed. Well, as we begin the relaxation, right, you see these AV valves are still closed, and blood keeps on returning to the right and left. And again, we talk about this being isovoluminic because the semilunar valves will close again. They'll close as soon as these ventricles relax so much that their pressure falls below that's in these tubes. So that blood will come back and they'll close these valves. So again, we're in this isovolumic or isovolumetric state, but of relaxation, right? Just a little bit longer and we will completely relax so that pressure is lower now, right, from here to here. Pressure is now lower in the ventricles than the atria, which means that these valves open again. And now blood starts moving in, so we call this the ventricular filling phase of ventricular diastole. Right? Now I mentioned over here too, just before, because I've kind of gotten a little ahead of these words on the side, but again, pressure drops, the semilunar valves close, as you see from here to here. So pressure is dropping because we're in ventricular diastole. No more blood can leave, and the volume of blood still in the ventricles at this point is called end-systolic volume. So this is basically the blood that remains in the heart. And again, this is a fraction of the end diastolic volume. It's a fraction of all the blood that had returned that we see over here. So end systolic, we're at the end of systole, how much blood is still in the heart. All right? And it says, again, as the ventricles continue to relax, pressure begins to fall. As soon as it's less than the atria, these AV valves open again, and we start the filling all over. Okay? And as shown previously, all four chambers are in diastole, right? AV valves are open with semilunars closed. So we're back to that beginning that was triggered by this repolarization. So this nice cartoon also, again, takes the electrical stimuli and it says, okay, here's what's going to happen, right? So atria were relaxing up until this point. Ventricles are still relaxing. Here would be when the SA node, right, depolarized, spread through the atria. At about this point, see there, atria begin contracting, right? But ventricles are still relaxed. So then we continue on the depolarization through the AV node and AV bundle, the bundle branches, Purkinje fibers, and we get ventricular depolarization. And about at the height of the R, right, we'll start the ventricular contraction, right? And at this point, about the same time, the atria will stop. So atria and ventricles will never be in systole together, but they will be in diastole together, as seen here and here. And so this shows one complete cardiac cycle, because about this point we'd start over again. All right? We say, let's add the sound effects to this, and this shows these pressure changes, which really are ultimately causing the valves to open and close. And this is a really nice image to show this. All right? So 1 and 2, or lub and dub, right, are the vibrations from these valves closing. So the first sound is going to be the AV valves closing. The second sound is going to be the semilunar valves closing. All right? So, and this would mark the beginning of ventricular systole, because at that point, right, pressure in the ventricles, shown by the green line, would go above pressure in the atria. All right? Now, it's still, ventricular pressure is beneath the arterial aorta, specifically here. And so at this point, again, from here to here, right, we'd be in the isovolumic or isovolumetric phase, right? But as soon as a contraction results in pressure above, right, above the aorta, the semilunar valves open. As long as it stays above, we're going to get blood leaving, right? Whoops. Sorry. And then, got ahead of myself there. And then as it falls, as the ventricles start to relax, as it falls, and of course this pressure drop also occurs because blood's leaving, right? We'd get to a point where pressure is now higher again in the aorta than it is in the ventricles, and so blood would start to come back, and it would close these AV valves, semilunar valves, and we'd get our second heart sound. Oh, that's a lot. So again, got a Kahoot to play. Really probably need to offer these for you guys as a homework, just so you can test your knowledge. All right. So the last part of this chapter really deals with this idea of making sure you meet your needs. So I think I will go ahead and stop this here, and we'll pick this up on the next video for consistency's sake.